It is October 11th, 2017, 3:39 p.m. Pacific time. You are currently looking at a live view of a recovered Falcon 9 rocket on the SpaceX launch pad as it awaits its second launch since landing back in February of this year. Welcome to today's webcast of the SpaceX EchoStar 105 SES-11 mission from Launch Pad 39A at Kennedy Space Center in Florida. My name is Tom Perderio and I'm a firmware engineer here at SpaceX. The first stage of the Falcon 9 rocket you see today on the pad was previously flown as the first stage of the CRS-10 mission, which was a mission to resupply the International Space Station earlier this year. Today we will deliver the EchoStar 105 SES-11 payload to satellite to a geostationary transfer orbit target, which is what you'll hear us call GTO throughout this webcast. Today's launch will be our fourth launch for SES. The first was SES-8 back in December of 2013, and the most recent was SES-10 in March of last year. This is also our second launch for EchoStar, the first one being EchoStar 23 in March of this year. And with previous GTO flights, geosynchronous transfer orbit, we will be attempting to recover the first stage of our rocket on the drone ship Of Course I Still Love You, which is currently stationed off the coast of Florida in the Atlantic Ocean. Launch Complex 39A is the same launch pad that launched the Saturn V rockets carrying the Apollo missions as well as the Space Shuttle. SpaceX leased this pad a few years ago and started launching from the pad at the beginning of this year. We've constructed a massive hangar that can house both Falcon 9 and Falcon Heavy, which of course has 3 first stage boosters instead of just 1. The vehicle you're looking at today was rolled out of the hangar and raised to vertical on the launch pad about 24 hours ago. As you can see in your stage, it's currently still mated to the transporter erector, which carries it out of the hangar. You can see the rocket has 2 stages. The first stage is about 70% of the height, and the second stage is the remaining 30%. These are both made of an aluminum structure connected by a composite interstage. On the very top is the fairing, which is made out of a composite material as well, carrying the EchoStar 105 SES-11 payload. Once that first stage launches today, it's also going to be attempting to return into the atmosphere and land on the drone ship Of Course I Still Love You, which is our East Coast drone ship. This will be our 18th landing, with the most recent landing attempt occurring just a few days ago on Monday, which was the Iridium 3 launch. Throughout today's webcast, I'll be bringing you status updates during the countdown and all the way through flight. The Falcon 9 that you're looking at today rolled to the pad late Tuesday afternoon and went vertical at about T-minus 24 hours. We've been loading propellants, which is our RP-1 and liquid oxygen, into the rocket since T-minus 78 minutes, which is the same as we've been doing for the last few flights. The current generation of Falcon 9 has its go, no-go pull at about T-minus 2 hours. And as you can see, that go, no-go pull went well, and we are currently in the process of loading fuel. Loading fuel on the second stage is nearly complete, and we're topping off on the first stage. LOX loading is in progress. We've done the initial load, and we're currently in a planned pause phase while we load helium to the final flight mass. Once we confirm we have enough helium, we'll resume LOX loading at about T-minus 2 minutes. Currently, the EchoStar and SES team has reported that their satellite is in great condition and ready for launch. The range is also reporting ready to support the launch today. The area was cleared, the entire area around Pad 39A was cleared for flight this morning and last night. At SpaceX, we monitor several weather conditions, one of which being low altitude winds, another being upper altitude winds, and also rules like anvil cloud rules and lightning conditions. As you can see on your screen, it is a beautiful cloud-free day at Cape Canaveral. Couldn't be more perfect weather for a launch. So with all stations currently indicating go, let's take a closer look at the countdown clock and watch the rocket as it approaches liftoff. Oh. As we said before, today's payload is the EchoStar 105 SES-11 satellite. As we're waiting for the countdown to get a little bit closer, let's take a look at exactly what this payload is. Reusability is the fundamental breakthrough needed to reduce the cost of access to space. A fully and rapidly reusable rocket, which has never been done before, is the key to establishing not just outposts, but also self-sustaining cities on other planets. Now, the cost of fuel for each flight of the Falcon 9 is only about $200,000 to $300,000, which is only about 0.4% of the cost of the rocket. The majority of the launch cost comes from building the rocket, which, if it only flies once, makes for a very expensive ride. However, recovering and reusing the rocket multiple times, the way a commercial airliner is reused over and over again, significantly reduces the cost of an individual flight, since the capital expenditure to build the vehicle can be spread out over many flights. Being able to reduce the cost of the rocket and reuse it has the potential and is the key to establishing a city on Mars. We need to get the cost of a launch down to a level where a critical mass of people can actually afford to go. Let's take a look at how the rocket is doing as we get closer and closer to liftoff. The first stage and the second stage of the rocket are almost fully loaded with about 1 million pounds of propellant and liquid oxygen in total. We'll continue topping off both fuel and liquid oxygen until about T-minus 2 minutes. At T-minus 7 minutes, we had an engine chill, which is when we flush those engine compartments of the Merlin 9 engines with cold liquid oxygen to get them to their operating temperature. The next few minutes here, as we get closer, here are the next things that are going to happen. First of all, that strong back transporter erector to the left of the rocket is going to retract slightly and then fully recline as the rocket leaves the pad so it can clear. The rocket is currently also pressurizing with helium. A good part of the rocket's strength comes from the pressure inside the tanks, and we use helium to create that pressure. At about T-minus 60 seconds, the rocket's internal flight computer is going to take over. You'll hear a call out on the launch net saying Falcon 9 is in startup. So let's recap. The payload is sounding, sounds like the teams are saying the payload is good to go, range is good, and weather is crystal clear. Let's listen in to the last few minutes of the countdown.
Stage 2 LOX load is complete. Vehicles and self-aligned. Vehicle gas closeout started.
AFTS is ready for launch.
F9 is in startup. Stage 2 bed press. T-minus 45 seconds. I'll be good for launch.
T-minus 30 seconds.
Stage 1 final flight press.
Minus 15, stand by for terminal count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Stage 1 prop looks good.
Power telemetry nominal.
You're watching the Falcon 9 rocket as it ascends through the atmosphere, carrying the EchoStar 105 SES-11 payload to geostationary transfer orbit after a successful liftoff from Kennedy Space Center in Florida.
Vehicle supersonic.
In about 10 seconds, the rocket is going to be passing through the period of maximum aerodynamic pressure that is called max Q. Those 9 Merlin engines currently thrusting produce the thrust of 5 747s at full thrust. That's how much power the Falcon 9 is producing right now.
And back engine shell started.
In about 30 seconds, those 9 Merlin engines are going to shut off in an event called MECO, which stands for Main Engine Cutoff. Once MECO happens, there'll be 2 other very quick succession stages happening after that. The first is going to be the stage separation, where the first stage separates from the second stage and comes back towards the drone ship. And then after that, second engine start 1, which is when the Merlin vacuum engine on the second stage ignites to carry the payload the rest of the way to orbit. Stand by for MECO very soon.
We have eco.
Stage separation.
And back ignition.
You can hear the applause from Mission Control. It looks like that we had a successful MECO, main engine cutoff, successful stage separation, and a successful start of the Merlin vacuum engine on the second stage. For those of you just joining us, on the left-hand side, you can see the first stage of the Falcon 9 rocket currently expanding its grid fins, getting ready for its ascent or descent back down through the atmosphere. And on the right-hand side of your screen, you can see the engine nozzle of the Merlin vacuum engine on the second stage. In about 10 seconds, we're going to see the fairing, which is protecting the EchoStar 105 SES-11 payload, deploy from that second stage. There it is. And you just saw a successful deployment of the fairing. Fairing is only needed while in the dense region of the atmosphere to protect it from aerodynamic loads. Now that we're out of the atmosphere, we can jettison it.
Acquisition of signal Bermuda.
You can see those cold gas thrusters on the left-hand side of your screen. Those help orient the first stage of the rocket so that it's pointed in the right direction as it comes back down through the atmosphere. So that first stage is currently pretty high up in the atmosphere. It's still, the gas of the atmosphere is still very thin up there. So as it approaches the much thicker parts of the atmosphere lower down, it's going to execute an entry burn in about 1.5 minutes. This entry burn is going to slow the rocket down so that as it hits the thicker parts of the atmosphere, it doesn't experience any excessive heating from compression of the atmosphere. When on the launch pad, the Falcon 9 rocket is actually, the weight of the Falcon 9 rocket is actually about 90% fuel. So right now that first stage is mostly empty, having expended most of its fuel to get the second stage up to orbit. That first stage, therefore, because it's so light, doesn't really need that much thrust to slow down. Those Falcon 9, the Merlin engines actually operate at full thrust regardless of how much fuel is in the rocket. So the entry burn is only about a minute long. Excuse me, 20 seconds long. Entry burn is only about 20 seconds long, starting in about a minute. Currently, we're getting good telemetry back from the first stage and the second stage. Trajectory is good for both. And the engine chamber on the Merlin vacuum engine is holding steady. We should be seeing the entry burn of that Falcon 9 first stage on the left-hand side of your screen in just about 10 seconds.
Stage 1 AFTS has saved.
And there's that entry burn beginning.
Stage 1 entry burn start.
Still getting good telemetry from the second stage as it continues to climb, carrying that EchoStar 105 SES-11 payload to its intended geostationary transfer orbit. We had a good entry burn, and the first stage is still on track to touch down on the deck of Course I Still Love You in the Atlantic Ocean.
Drone ship AOS.
So we don't currently have signal from that first stage, but it is scheduled to start its landing burn in just about
Stage
30
1 is
seconds.
transfer.
Currently the second stage, as you can see on your screen right now, is still burning happily. We have good telemetry from the second stage. Still on course for a geostationary transfer orbit.
Stage 1 landing burn has started.
Stage 2 AFTS has saved.
This is video from the drone ship, Of Course I Still Love
Landing
You.
legs have deployed.
And a brief cutout in video there, but as you can see, Falcon 9 rocket is currently standing on the deck of Course I Still Love You. Yet another successful landing of the Falcon 9 first stage. This is our 18th successful landing of the Falcon 9 rocket. We also had a confirmation of a good second engine cutoff. This is currently right now, the second stage of the rocket is in a coast period. This coast period is going to last about 20 minutes, but we're not going anywhere. We're just going to give you a quick animation showing exactly where the second stage of the payload is over the surface of the Earth. But we'll be back in just about 20 minutes to guide you through the rest of the second stage burn and payload deploy. Don't go anywhere. Welcome back. We are currently watching the second stage of the Falcon 9 rocket carrying EchoStar 105 SES-11 as it passes over the equator just over the west coast of Africa. We are coming up on our second light of the second stage engine. This is called SES-2 in just about 40 seconds. This second stage engine second burn is going to bring our velocity up from about 7.4 kilometers per second to 9.5 kilometers per second. This second burn is only going to last about 1 minute, coming up in about 15 seconds. You're looking at live video feed from the second stage of the rocket. Stand by for second stage engine light. And there it is, a successful relight of that second stage engine. Currently, that Merlin vacuum engine is putting out 210,000 pounds of thrust, which adds a lot of impulse to a mostly empty second stage tank. We're getting great telemetry from the burn. Turbine is healthy. Engine chamber pressure is good. And the engine output power is also good. SpaceX has ground stations around the world. We are currently receiving good telemetry from the rocket, but video data doesn't always come down as smoothly as expected. So currently we're watching an animation. And it looks like a good burn. We're having telemetry looks good. Orbit is looking good from that second stage after that second stage engine burn. So right now, the next step in this mission is to deploy the EchoStar 105 SES-11 payload. However, that doesn't happen for about 8 or 9 minutes from now. So we're going to go back to the animation and watch the second stage and payload circle the Earth. We will be back in about 8 minutes to guide you through the deployment of the payload. Welcome back again. For those of you just joining us, just a few minutes ago we had a successful second burn of the second stage engine, which gave the payload, the EchoStar 105 SES-11 payload, its final kick, getting towards geostationary transfer orbit. Coming up in just about 40 seconds is the final stage of the Falcon 9's mission today, which is deployment of that satellite. Currently, the EchoStar 105 SES-11 satellite, which you can see on your screen right there, is attached to the Falcon 9 second stage via a payload adapter fitting, which includes some bolts and springs. When we give the command in about 20 seconds, those bolts will release and the springs will give the satellite a gentle push from the nest so it can begin its journey the rest of the way towards geostationary transfer orbit. So stand by for payload deploy in about 10 to 20 seconds. On your screen, you can see that satellite now.
Payload deployed, confirmed.
And there it is. You can see the EchoStar 105 SES-11 satellite successfully deployed from the top of the Falcon 9 second stage, gliding away into space. So with that, we are going to bring this webcast to a close. We'd like to thank our customer, both EchoStar and SES, for supporting this launch today. Also, a big thank you to the U.S. Air Force Range and the FAA for supporting us today for this launch. And we'd also like to thank you, the viewer, for tuning in. If you'd like to be part of the mission here at SpaceX, please check out spacex.com/careers and look to our social media pages and website for information on future launches. Thank you so much.